again, and in this session we are going to start with a chapter which is called as, let me write the chapter name. The chapter is called as First Order and First Degree ordinary differential equation. Okay, ordinary differential equation. Okay, but before beginning with this chapter, I want to remind you all the formulas of integration, because in this chapter integration will play an important role. So integration you should know, but I will try my best to tell you all the formulas whichever are needed. Okay, I am going to tell not all, only needed one. Okay, needed one in this chapter. So let's begin with the formulas. So the formulas which you need to learn, the first formula is as follow. The first formula is, I will take it A, integral what, x power n the whole upon x power n the whole upon x power n into dx. Integral of this is nothing but, okay, so integral of this is nothing but x power n plus 1 the whole upon n plus 1 plus c. Okay, and n should not be equal to minus 1. Now just see this application of it. Integral ax plus b power n into dx will be what? It will be nothing but ax plus b power n plus 1 the whole upon n plus 1 plus c. Okay, and here n should not be equal to minus 1, here plus c will appear. After this, the second formula which you need to learn is a integral 1 upon x dx. What it is? Its integration is nothing but log x, and with a thing which is plus c, and here the b which we will take an example of it, which is ax plus b, and integration of this will give you nothing but, okay, sorry, I forgot to do the differentiation of it. Okay, remember, whenever you do integration of any polynomial function, its differentiation occurs in the denominator in case of while you are integrating. Okay, so whatever, no matter what formula you run, you indirectly need to differentiate if there is a chain function here, okay, or a f of g of x type function. So here, if I told you to integrate this, it will be nothing but log ax plus b the whole upon integration of ax plus b is what? A, and here plus c. Do you agree with this? Now let's move on to the third formula, which is nothing but we will consider a type, which is integral e power x dx, right? It is nothing but e power x only and plus c. Now just see this example on it, e power minus 2x dx. Its integration will be what? Its integration will be minus 2x as per this. Okay, here it tells that integration of e power x dx is nothing but e power x plus c. So here we put e power minus 2x plus c, but it will be wrong. We need to do the differentiation in the denominator, which is minus 2. Okay, so indirectly you need to differentiate, which they never mention in the formulas. Okay, the formulas are straightforward. Now, fourth question is what? Integral a power x dx is nothing but a power x the whole upon log a. Okay, plus c. Now, the next formula after this we will not take example on this. Now some standard formulas will appear, which will have chain rule, but for the timing we will just understand them. So integral sin x dx, its answer is very straightforward, minus cos x plus c. And now see the integration problem which you will face with it. If I give you this and tell you to integrate, if you write here minus cos ax plus b plus c, your answer will be wrong. You need to differentiate it in the denominator. Differentiation is very crucial. If you forget, your integration will be wrong only. Now let's see the sixth formula, which is cos x integration. So cos x dx is nothing but sin x plus c. Now for this part it is very simple formula, but when a question you will see, you may forget the chain rule, because of which many students gets wrong answer. Cos 3x dx is nothing but what? Sin 3x the whole upon 3 plus c. So you just need to focus on the formulas, because they are very important. If you don't focus on the formulas and just forget this chain rule, then your answer will be wrong. So chain rule plays very important role. Now let's see the seventh formula, which is integration of tan x, which will be log mod sec x plus c. Now there is one more formula I know, but it will not be required for this chapter, so I am going to avoid it. So after this, cot x dx is nothing but log mod sin x. You need to never get confused here. It is sec. Many children do what they think, that if tan has second formula, then cot will automatically have what? Sin opposite cosec, which is very wrong. It will have sin x. After this, see the ninth formula, which is integration of sec x dx, which you know it is nothing but log sec x plus tan x plus c. After this, the 10th formula is integral cosec x dx. It is nothing but log mod cosec x minus cot x plus c. After this, the 11th formula, which you will see, is integral sec square x integral sec square x dx is nothing but what you can write it. Just here you need to remember the differentiation opposite. Okay, all the things will be just opposite of differentiation. So we know that tan x differentiation is sec square x, so sec square x integration will be tan x plus c. Now the 12th one is nothing but similarly its brother cosec square x dx. It will be nothing but minus cot x plus c. So don't do any mistakes, just remember all these formulas. 1 upon a square plus x square dx is nothing but 1 upon a tan inverse x by. Now see what the problem in this formula is, that when you will study, okay, here in many books you will see 1, so the formula becomes tan inverse, okay, x. So they don't mention here 1 by a, so this one is good. Okay, you need to memorize this one, a square. Just don't try to get confused if here 1 is present. It is nothing but here if we don't need to represent this one, so it becomes like this. Now the 14th formula which you will see is 13th. Did we missed any formulas? Integral. Okay, so the next formula which I have is x upon a square plus x square. Okay, its integration, you straightforwardly need to revise that its integration is nothing but 1 by 2 log a square plus x square. Just remember this, it will be just be useful for you. Now after this, the next formula series are 1 upon under root type formulas. First you will see a square minus x square dx. You can directly make out that this is nothing but sine inverse x, so I will write the sine inverse x by a, but its alternate ego exists, which is nothing but if they give you x square minus a square like that. Okay, but before going with that, let me take this one similar to this, a square plus x square. What you will write in this case into dx, it is nothing but log x plus under root a square plus x square. Okay, now let's move on to the next. Here all will have plus. Okay, I am not mentioning it, doesn't mean that they will not be present. After this we will see one more formula which is just the opposite of this one. Okay, this one opposite of this one, which is 1 upon under root x square minus a square. So these are what? These are combination of 1 upon under root type formulas. So what it will be? It will be nothing but log x minus under root x square minus a square. Let's see. 18th. In 18th, what you can see is this type of formulas, okay, will be a combination of nothing but under root dx type formulas. Okay, so a square minus x square dx. You need to just memorize this, x by 2 under root a square minus x square plus a square by 2 sine inverse x by a. And you can also learn this formula like 1 upon under root yahi into log x plus x minus yahi, this thing. Okay, you just need to just substitute this thing here only, and here it will be x, like that. Okay, there are many different ways to memorize the formula. It depends completely upon you how you want to memorize the formulas. So the next one is, okay, let me take the eraser suddenly. Okay, let me take the eraser. So the next formula which you will see is, I'm changing the pen, it's nothing but under root, okay, it was under root a square plus x square dx. It is nothing but x by 2 under root a square plus x square plus a square by 2 into log x plus yahi x plus a square plus x square. So here why sine inverse x appeared, because you can see it is a formula of under root a square minus x square, so sine inverse x will appear. So you can make a hint from this formula structure. Okay, now let's take the next example, next formula, which is integral e power. Now it will be e power type formulas. You just need to e power although you can get these answers by using UV, okay, means finding the integration of products using that, but if it's better to memorize this e power ax the whole upon a square plus b square bracket a sine what it is bx plus c minus b cos bx plus c. 21th, if you see, it's just similar to this one, e power ax cos bx plus c integral dx is equals to nothing but it will be e power ax the whole upon a square plus b square, but the difference will be that here cos will appear, here cos bx plus c plus b sine bx plus c. Now here why negative didn't appear? Because you can make out that cos, okay, when you apply chain rule, integration of cos x will appear, it will be sin x, okay, because of which here positive will be there. After this the next formulas which we will see is, okay, this one is very common and you must need to memorize this, that is integration of log x dx. Okay, here we consider one, remember, and apply the UV formulas. So just memorize it. Its answer is nothing but x log x minus x. You need to memorize them. 23rd, which you need to memorize is this UV rule. Okay, using this we got what? We got this formula, we got this formula, we got this formula. So you need to memorize this UV dx. You must have studied this in your class 12. U integral v dx minus integral du by dou x integral v dx the whole bracket dx. Okay, so this thing you need to memorize. And how you select u and v? Using eyelet, but light or eyelet, whatever you feel comfortable. Okay, but I will use light, L-I-A-T-E, light. Logarithmic, okay, algebraic, trigonometric, exponential, now inverse. Okay, now what we will move on, we will see one more modification of this formula and then we are done with. The modification of this is uv dx is nothing but u v1 minus u dash v2 plus u, okay, what u double dash v3 minus u triple dash v4 and so on. Now what are u and v here? U and v are nothing but u dash is nothing but dou u by dou x, u double dash is nothing but u dash is nothing but dou u by dou x, dou du by dx, sorry. U double x is nothing, double dash is nothing but u dash upon dx, okay, and u triple dash is nothing but d double dash upon dx. Similarly here v1 is nothing but integral v dx, v2 is nothing but integral v1 dx, and v3 is nothing but integral v2 dx. So you just need to memorize, okay, memorize all these things. Now we will take some example on this end one because they are important and you may feel difficulty in them. Now one more thing which I forgot to mention, that that you should keep the check in on these points, that these formulas are applicable on algebraic, trigonometric and this one, okay, only this 24th one, okay, I'm talking about 24th one, algebraic, trigonometric and exponential. If from these three any two combination are found, okay, as a product, you can use directly this instead of going with the classical formula. Now let's take some examples for better understanding. so that you can get easily whatever you so let's take one question. The question is, if I take this question, integral x power 4 e power minus 3x dx is nothing but x power 4. Okay, here you can make out using light that here algebraic is what? Okay, algebraic is and exponential is last, so you can make out what is v. V is what? Exponential one. V is nothing but e power minus 3x and u is nothing but x power 4. So I will apply this direct formula, x power 4 integration of e power minus 3x dx, then minus x power d du by dx du by dx. So here we will do here we will differentiate what? X power 4. Okay, and the whole will be integrated. After this there will be integration of again what? E power minus 3x, right? Okay, and that's it. So you have to continuously keep doing it until you get the this term eliminated. Okay, this term will become small and small after some time. So this will keep on going. So if I try to solve it, minus 3x by minus 3 minus 4x power 3 e power minus 3 x upon what? Here it will be what? Like here it was e power 4x cube. So if I integrate this, okay, what it will be? Minus 3 into, remember what I mentioned earlier, that here whatever you are integrating will be what? Will be v1. Remember, this is what? V, and this will be what? v1. So here you will be integrating what? Minus e power minus 3x upon minus 3. So if I integrate, I will again get minus 3 here, and minus 3 is still present here, so I will get here 9. Okay, after this here you will differentiate this one. So what you will get? Here again minus sign will be there, but it will become plus, so 12x square, and when you integrate this one, it will become e power minus 3x upon minus 27. Similarly it will keep going on. Now if you differentiate this again with here negative sign, positive, negative, positive, negative, like this alternatively it will keep on going. 24x e power minus 3x, and here when we multiply it with minus 3, and again it will become plus 81, right? And if it is plus minus, then after it will be what? Plus. So what we are going to get? Only 24, and here we will stop, which will be nothing but 243. So hope you have understand how to do the algebraic trigonometric and exponential. So let's take one more example. So the example is integral x power cube minus 4x square plus 7x into cos 4x dx, right? So here you have to identify what is your u and what is your v using, okay. So here what you observe, A is algebraic, this is algebraic, this is trigonometric. Okay, so this is my u, this is my v. So v will be integrated and u will be kept as it is. So x cube minus 4x square plus 7x will be as it is, and if you integrate this, what you will get? Cos will be sin 4x upon 4, right? Then here minus will appear, 3x square minus 8x, right, plus 7, and here if I differentiate, integrate this one again, I am going to get minus cos 4x by 16. After this we will continue keep doing this. And here what we are going to do, we are going to, now plus sign will appear and we will differentiate this one, which will be 6x minus 8 into, if I integrate this one, it will be minus sign 4x the whole upon 16 into 4, 64. Now plus after this minus sign, and we will differentiate this one, which will give me 6, and after this I know I am going to stop, which will cause 4x, here minus will be there, so it will become plus upon 64 into 4. So after this you can solve. So my whole intention was to just to make you comfortable on how to solve algebraic, trigonometric and exponential using this method. You okay? So hope you have understand this. Now let's take one example, one more example, so that you understand the things more properly. Under root x square minus y square dx dx. If we take this question just for the sake of revision, how you will solve this? They are both what? Okay, let me write it properly. So if I write it properly, what I have here, integration, what I have to integrate, integrate what? Under root x square minus y square x dx. So what we are going to do, put x square minus y square as t. What you are going to get, if you differentiate it with respect to x, what you are going to get, you will get nothing but x, 2x, right? You will get 2x dx is equals to dt. Now you can substitute x dx x dt by 2, and here you can substitute here as this t, and this will be dt by 2. 2 will move outside, and you have to integrate t under root t dt, which will give you straightforward answer as nothing but, which is t power 3 by 2 upon 3 by 2. 2 will cancel out, and your answer will be t 3 by 2 by 3. And if you resubstitute the t value, which is x square minus y square the whole upon 3 by 2 the whole by 3. So this is your answer. Hope we have revised integration. In the next session we will begin with the lecture of first order partial differential. We will begin with the chapter of first order differential equation. So please revise all the formulas and see you in the next lecture.